All right, guys, so let's take a look at what you have there in front of you with the whole rates and slope of the line business. Um, so let's take a look at what's going on here. It says the graph below shows data from a call assistance center. At what rate are calls being handled? Okay, so they give you kind of a picture of a line here. And all I'm trying to do is figure out at the rate, the way the calls are being handled. So let's take a look here. Guys, what do you think this point right here really means? This one right here. Why is it not marking? Boo, hale. There we go. Okay, so what does this mean? At 10 a.m., how many calls had they received? 30 calls, right? Okay, so we're gonna go like this. 10 a.m., right, they had 30 calls, okay? What does this mean? So look, just the same way we did this one. We said at 10 a.m., they had received 30 calls. What does this thing mean right here? There you go. So at 1 p.m., they had how many calls? 90 calls, right? Okay, so we're going to try to find, guys, we're going to find the rate, okay? What I mean by finding the rate, how many calls did they receive in that time frame? How many calls had they received from 10 a.m. to 1 p.m.? How many calls did they get? 60 calls, okay, right? So let's figure out, how did we get 60? We said 90 minus what? 90 minus 30, right? How many hours had passed? From 10 a.m. to 1 p.m., how many hours had passed? 3 hours, right? Okay. So 90 minus 30, we said, was 60. So that means that they had 60 calls in 3 hours, right? So what rate would that be? Every hour they're processing how many calls? There you go. 20 calls per hour. Does that make sense? Pretty straightforward? That one was, right? Okay. Well, let's take a look at the next one and let's see if we can figure out what this one is telling me. Okay. So guys, it says the graph below shows the population of Cleveland, Ohio. At what rate was the population changing? Okay, so let's take a look here. All right, so I want to see again, what does this point really tell me? So guys, if I look here, this is the population of Cleveland in what though? In thousands, right? So look what it says. In the year 2000, yeah, Cleveland had 475,000 people. But then in what year would this one be? 2000 what? 2010? What was the population of Cleveland there? 375,000? Okay. All right. So guys, we're going to do the same thing that we did before. We're going to find the rate. Okay. So we're going to find the rate. Let me ask you a question, guys. Is the population of Cleveland going up or is the population of Cleveland going down? It's going down, okay? So guys, when I subtract, I'm actually going to do it like this. I'm going to say 375 minus 475. How many years had elapsed here? In a 10-year period, right? So this is the population. This is in years, okay? Anybody know what's 375 minus 475? 375 minus 475? Negative 100, right? Okay, negative 100 over 10 years, okay? Guys, anybody know what's 100 divided by 10? 10? Positive or negative? What do we got here? There you go, okay. So negative 10, isn't this in thousands? Right? So let's figure out what that's telling me, right? We said the population of Cleveland was going up or was going down? It was going down, right? Because in 1 year, in 2000, there was 475,000 people living there. In the year 2010, there was only 375,000 people living there. So what that's telling me is that every year, on average, 10,000 people were leaving Cleveland, right? That's right. So let me ask you a question. Very good. What did we do with those numbers right there? We subtracted them, right? Guys, didn't we essentially do the same thing here? Didn't we really subtract those numbers as well? Right? 2010 minus 2000 was 10 years. Didn't we do the same thing in this problem? Didn't we say, look, at 1 o'clock we had 90 calls, at 10 a.m. we had 30 calls? Didn't we subtract those numbers right there? Guys, anybody here ever been in the military, or y'all know military time? Okay, okay, some of us are in the military. Jordan? Okay, so Jordan, let me ask you a question. 1 o'clock. What's military time for 1 o'clock? 13, right? So guys, 10 a.m., couldn't we just say 13, right? Hour 13? Aren't we still subtracting 13 minus 10? Doesn't that give us 3 hours, right? So all we're doing is subtracting and then dividing, right? Let's see, I think we got another one. Here we go. We got another one right here. So let's see if we can't figure this one out. Okay. All right, look what it says. Train travel. The following graph shows the data from a recent train ride from Denver to Kansas City. At what rate did the train travel? Okay, so let's take a look here, guys. This is the distance in miles. Okay, let me see if we can figure this one out right here. Okay, so this looks like it's at 3 o'clock, right? So at 3 p.m., what mile would they be at? If this is 250 and that's 300, what's going to be right in the middle? 275 miles, right? And then this one here, this looks like that's what, 5 p.m.? Oops, p.m. They're at what, 450 miles? Okay, so guys, if we're going to find the rate, just like we did before, what two numbers am I going to subtract? Okay, so let's go 450 minus 275, right? And then, are we going to subtract those numbers too? 5 minus 3? Okay, so guys, anybody know what's 450 minus 275? Anybody got a calculator? 450, 275. I'll give you a hint. 5 minus 3 is going to be 2. 175. Okay. So that's 175. Everyone agree that's miles? And isn't this hours? Because those are times. So anybody know what's 175 divided by 2? It's going to be a decimal. Okay, so guys, what that's telling us, the speed of the train, 87.5 miles per hour, right? Because we know at 3 o'clock they were at 275 miles. At 5 o'clock they were at 450 miles. So in that time frame, they were going on average 87.5 miles an hour, right? Okay. Alrighty. So guys, do me a favor. Go to the next page. If it's here, here we go. Okay. Did I skip one or no? No, we're good. Okay. All right. So, guys, the way I'm going to do these problems, very similar to what we just did, okay? So it says, using the slope-intercept equation to model data, part 2. And let's take a look here. And it says, the slope-intercept form of a line is given by the equation y equals mx plus b, where m is the slope of the rate of change, and b is the fixed amount. And then here's a little formula for the m. Guys, what we've been doing right now, we've been finding that m by taking the differences and subtracting, okay? This is what we call the slope of a line. I'm going to show you what that means in a second, okay? So let's take a look here. It says, the Bettis family is thinking about switching cell phone providers and is interested in the family plan. The plan has unlimited talk, text, and data for a fixed cost, and the total cost is based on the number of phones for each family. Use the table below to answer the following questions. All right, it says, find the rate at which the company charges per line. So let's take a look here, guys. When we have 2 phones, they're charging us $110. When we have 4 phones, they're charging us $140. Now, I'm going to get the calculator going right here, guys, because, let's see. A lot of times what people want to do, sort of the first instinct is to say, well, look, why don't I take 110, and how many phones did we have there? And divide it by 2, right? And if you do that, okay, look, that's $55 per phone, right? But does it work out the same way if we take 140 and divide it by 4? No, it's $35 a phone. Okay, so it doesn't work. I can't do it like just by dividing those numbers. But what we can do is we can say, let's do the slope. Okay, let's do the m. Guys, if I'm paying 140 for 4 phones and I'm paying 110 for 2 phones, what's the difference between those two? Meaning, I'm going to subtract those numbers again. Okay, and then I'm going to subtract the number of phones. So I'm going to go 4 minus 2. Okay. So what's 140 minus 110? $30. Okay, 4 minus 2 is 2. So 2 lines, 2 phones, whatever you want to call it. So guys, what are they charging me per phone? Yeah, $15 per phone. Does that make sense? Okay. That's it, right? And isn't it kind of what we did like in the problems before? But the problems before, we had the picture. Here, there's kind of given to me in a little table, right? All right, so now look what it says for the next part. It says, what is the fixed cost? How much does it cost for the general service regardless of the number of lines? Okay, so guys, I want you to notice I have an equation right here that says y equals mx plus b. So the first thing I'm going to do right here, guys, I'm going to write this out. Y equals mx plus b. Okay. All right. Guys, if I look at this piece right here, what I'm trying to find right now is I'm trying to find my fixed amount. Okay. So I wanted you to think about this for a minute, and we can use either this piece of information or this piece of information. We'll end up with the same thing. What I'm going to do is my total cost is going to be sort of my Y number, and the number of phones is going to be sort of my X number. So if I were to say use this point here, where the Y would be, I'm going to write the number 110 equals, didn't we just find a number for our M? 15, right? Okay. Well, my phone bill is $110 when I have how many phones? When we have 2 of them, right? Okay. Now we just need to find the value of B. So what I'm going to do now is we're going to take 110 equals, what's 15 times 2? 30. Okay. Plus B. Guys, if I want to get the B by itself, I'm going to go ahead and subtract 30 on both sides. Okay. And anybody know what's 110 minus 30? 80, right? Okay. Guys, this is my fixed cost. Okay, this is my fixed cost. Now, I want you to look at part C. Part C says, write the equation that describes the cost C in terms of the number of phones P. Okay, so instead of me using Y and X, they're telling me, hey, look, let's use C and P. So I'm going to write like this. C equals, remember the number we got for our M? 15, right? Times the number of phones P plus 80. Okay. That tells me that's how much I'm going to pay based on how many phones I have. Okay. So guys, we can always test it to make sure this is really going to work. Okay. So remember what we said earlier? Let me get my eraser so I can erase some of this mess right here. Okay. Let's test this to make sure this is really going to work. So based on this equation here, if I have 2 phones, my bill should be how much? 110. So look, what I'm going to do, I'm going to take 15 times 2 phones, and then I'm going to add 80 to it, because that's my fixed cost. That's what I'm going to pay regardless of how many phones I have. Okay. $110, right? So far it works. Let's try it with this one over here. So I'm going to take 15 times, how many phones do we have here? 4. Okay. Equals. Now if I add 80 to it, do we get 140? There we go, right? So when I'm doing something like this, guys, the idea is once I find my M, and remember how I found my rate, I said, well, look, if I'm paying $110 for 2 phones, and I'm paying $140 for 4 phones, how much am I paying per phone based on that information, right? So, well, I'm paying $30 for another 2 phones. I'm paying actually $15 per phone, right? Okay, so let's take a look at the next one, see if we can do the same kind of thing here. And it says, Directly TV is a cable company that charges a fixed amount for a basic cable package and an additional fee for each premium channel. Use the information in the table below to answer the following questions. Okay, so it tells me if we have If we have 3 premium channels, we're going to pay $85.99. And if we have 5 premium channels, we're going to pay $109.99. Okay, so let's figure out how much they're charging me per premium channel. Okay, so guys, remember the first thing I'm going to do is I'm going to take the difference between those two numbers. $109.99 minus $85.99. How many extra channels did we get? 2 extra channels, right? Because we took the difference, 5 minus 3. Okay. All right, guys, anybody know what's $109.99 minus $85.99? $24, okay. $24. So how much are they charging us per premium channel? $12 per channel, right? Okay, $12 per channel. Right? All right. So now the next thing I'm going to figure out is, well, how much would I pay if I didn't want to have like the basic cable, if I didn't want to have any like HBOs, anything like that, right? I just wanted to have the basic cable package. Let's figure out how much we would end up spending, okay? So guys, I'm going to look down here because I want to say Part C, which kind of got chopped up over here. But look what it says. Part C, write the cost of a cable bill for P premium channels. Okay, so instead of using Y equals MX plus B, I'm going to write it like this. C equals MP plus B, okay? This is the number of premium channels that I have, and this is my cost. So guys, one thing I want to point out, it doesn't matter which one of those 2 pieces of information I use, whether I use the 3 channels for $85.99 or whether I use the 5 channels for $109.99, I'm going to end up with the same answer, okay? So just to show you, suppose I decided to go with this one here. My cost is $109.99. What were we paying for premium channel? $12. When we have 5 premium channels, let's figure out how much the basic package is going to be. So first thing I'm going to do here, 12 times 5 is 60. Okay. $109.99, okay. And now we can, what, subtract 60 from both sides? Okay. Anybody know what's $109.99 minus $60? There you go. $49.99, right? Doesn't that sound like something? That's how much it's going to cost you. Right? All right, so guys, now let's go ahead and write out the equation. Remember we said we're paying $12 for every premium channel, and then $49, oops. Oh, come on. $49, that looks real messy right there. Let's fix that. Oh, man. $49.99 for the basic package, right? And again, guys, I can always check my answer. So we know we did it with the 5 and the 109. I could always check it with the 3 and the 85, right? So if I were to take $12 times 3, 36, plus $49.99, $85.99, right? Boom. So it's working out, okay? All right. So far, we're doing okay? Yeah? It's good? Why? What, this? No. I did this actually like 2013 or 14. Yeah, we used to do another class like this with this part here, and that's where I pulled it from. But true story, this is what I used to have a 2007 Dodge, and I sold it. All right, so let's take a look. That says cars typically depreciate at an annual rate. Use the table below to find the following question in regards to a 2007 Dodge Ram 1500 quad cab pickup. All right, so look what it says. 3 years after we bought it, the truck is worth $16,200. 6 years after we bought it, the truck is worth $9,900. Guys, is the truck going up in value or down in value? Down. Okay, so we're going to find the rate at which it's depreciating. Depreciating is just a fancy word for saying it's going down, right? We're losing value. Okay, so we're going to take 9,900 minus 16,200. How many years have elapsed here? 3 years, right? In a 3-year time frame. So let me take my calculator, move it over to the side. Oops, move it over to the side. 9,900 minus 16,200 is, it looks like it went down $6,300. Okay, so negative 6,300 over a 3-year period. So very good. It's going down in value $2,100 per year. Okay. All right. So we know at what rate the value of the vehicle is depreciating, right? Guys, let's take a look now. It says, how much was the vehicle worth when it was first purchased? Okay, so we can figure this out again, guys, by looking at these pieces of information here, okay? So it's up to us to decide which one do we want to use. Do we want to use the 3 and the 16,200, or do we want to use the 6 and the 9,900? Okay. Let me ask you a question. How do you think I could figure that out? So think about it this way. We know every year it's going down 2,100, right? Okay, add 16. So 16,200. What are you going to add to it? 3 years of what? 2,100. Okay. So would you do this? Would you say, look, let me clear this out. We're going to take 2,100 times 3, and then we're going to add it to how much? Okay, 16,200. Okay, boom, 22,500. Does that make sense? Does it make sense on how we're able to figure that out? You shall sure? Okay, no? Okay, so think about it this way. We know, so Fred, why did you say we should do it this way? I agree with you, but what are you telling me, like, how are you figuring that out? I'm trying to make sure that everybody understands.
Well, you see, in its third year,
it was worth
16. So if you want to know,
what was it worth 3 years before, right? Okay, so we know every year it's going down 2,100. So that means 3 times 2,100. Didn't it go down? It went down, what, $6,300 in those first 3 years? And if the truck right now is worth $16,200, if we add that back, that means it would have been worth, what, $22,500? Does that make sense? All right, so the truck was worth $22,500 when it was first bought, right? Guys, let me ask you a question. Could we have also said, look, it goes down $2,100 every year. We know in the 6th year it was worth $9,900. Could we have taken 2,100 times 6 and then added it to the 9,900? What do you think? Still works? Either way, you get the same thing, right? Because all you're doing is you're trying to figure out what was it worth when I first bought it, right? Okay. Now, the question says, write an equation describing the value V in terms of the number of years T. Okay, so what's the value of the truck? Well, the value of the truck is going down $2,100 every year for every year T. Plus, what was it worth when we first got it? $22,500, right? Boom. And there you go. Okay. All right. So let's see, I got another problem similar to that. Let's take a look here. It says Mondo has started an exercise and workout regimen so that he can lose weight. Use the table to answer the following questions. Okay, so it says in the 5th week of his regimen, he weighs 185.5 pounds. In the 10th week of his regimen, he weighs 178 pounds. Let me ask you a question. Is he losing weight? Okay, how would we figure out how much weight he's losing? What are we going to do? Subtract. Okay, so 178 minus 185.5. He lost a total of 7.5 pounds, right? How many weeks had passed? 5 weeks. Okay. So if we just divide that out, divided by 5, how much weight is he losing every week? 1.5 pounds per week. Guys, why is it a negative? Because he's losing weight, right? So the negative is important here. Just like in the problems we did before, sometimes it was positive, sometimes the negative. The sign actually means something, right? Okay, so let's see if we can figure this out. Now the next question says, how much did Mondo initially weigh? Anybody have an idea how we could figure this out? How much did he weigh before he started this? Okay, so we're going to add a pound and a half for each week. So if we're going to use this one here, wouldn't we take a pound and a half times 5? So 1.5 times 5, 7.5. And how much was he weighing after 5 weeks? 185. So wouldn't we just add that? 185.5, 193. There you go. Okay. Mondo was weighing originally 193 pounds. Okay. And now it says, write an equation that describes Mondo's weight, M for Mondo, right? Based on the number of weeks, W. Okay, so we're going to go like this. Mondo. Okay. Every week, he loses 1.5 pounds. So negative 1.5 times W. Plus his initial weight. How much did he start off at? 193. Boom. There we go.
So that's part C.
How would I write out like an equation, right? So now think about it this way. So we know that at 5 weeks he weighed 185, right? And at 10 weeks he weighed 178. Suppose you wanted to figure out what was he weighing, I don't know, say 15 weeks into it. Well, I would take 1.5, oops, let me clear that up. Negative, my bad, 1.5 times 15, right? And then I would add it to 193. So 15 weeks into it, now he's going to weigh 170.5 pounds, right? Does that make sense? And we could kind of keep doing that, right? Or so, suppose we said something like, suppose Mondo's goal is to weigh, I don't know, 160. How many weeks would it take him to get to 160, right? And we could kind of figure something like that out. But basically, that formula that we wrote right here, Fred, kind of will tell me all that information, right? So if I know how many weeks he's been working out, we can know his weight. If we want to know what's his target weight, we can figure out how many weeks it would take him to get there. All right, good deal. So guys, got another couple of problems here. We're going to try to figure out the same sort of thing, okay? And let's take a look. It says use the slope-intercept equation to model data. So same kind of equations we've been dealing with before. The y equals mx plus b. M is my slope, my rate of change. B is my fixed amount. So let's take a look here. It says a plumber charges $23 an hour for house calls plus a service fee of $40. Use the slope-intercept formula line to model the cost C in terms of the time T hours. Okay, so guys, what we're going to do here, we're going to write an equation, and it's going to look like this. Okay. C equals M times T plus B. So remember, M is the rate, and then B is going to be our fixed amount. Okay. So M is my rate of change, B is my fixed amount. So let's see if we can write out an equation here. How much does the plumber charge per hour? $23 for every hour. So guys, T is standing for my number of hours because T is time. Okay. Plus $40 just for them to go out there, right? So the plumber just shows up at your house, says, hello, I'm here. You already owe them how much money? 40 bucks, right? And then for every hour that they're there, another 23. Okay, now let's take a look at the next part. The next part says, how much would the cost be if the plumber worked for 3 hours? Well, wouldn't we say, well, look, 23 times how many hours? Times 3 plus 40, okay? Let's see if we can figure that out. So I'm going to take my calculator right here. 23 times 3. So that's what, 69 plus 40? $109, right? And maybe we should change our majors to plumbing, right? Okay. Look at the next part. It says, the plumber sent an invoice for $224. How many hours did the plumber charge for? So guys, I'm going to use this equation right here, okay? And the 224, was that the number of hours or was that the cost? That's the cost. So where that C is, I'm going to write the number 224, okay? Equals 23 times T plus 40. Now let's think about this for a minute. Didn't we say if the plumber just shows up at your house and says, hello, I'm here, you already owe him how much money? Okay, so let's take away that 40 because we know that we had to pay him that to begin with. So if I take my calculator, guys, okay, minus 40, yep, 184, right? Boom, 184, okay. So 184 equals 23T, right? And then we said the plumber charges you $23 for every hour that they're there. Well, if we know that we were basically paying them 184, we got to divide that number by what? By 20 what? By 23, because that's how much he's charging every hour, right? Or she's charging every hour. 8 hours? And again, all we did was divide it by 23, right? All right. So let's take a look at the next one here, guys. I'm going to try to do the same sort of thing. It says the cost of manufacturing computer desks is $80 per desk with a fixed cost of $5,000 for operating costs. Use the slope-intercept from line to model the cost C for X number of desks. Okay, so guys, the equation that we're going to write out is going to look something like this. C equals mx plus b. Okay? So we're going to say C equals, how much does it cost to make every single desk that they make? $80. Okay. Fixed cost, guys, the fixed cost is like, no matter how many desks we make, we still got to pay the light bill. We still got to pay the rent. We still got to pay the water bill. How much is that in this case here? The 5,000, right? That's our B. Very good. That's our B. So there's my equation, right? C equals 80x plus 5,000, right? So the 5,000, again, that's like your rent. That's like your power. That's your water bill, all that kind of stuff, right? Now, look what the next part says. It says, find the cost of making 200 desks. So remember, X, where we go? Tells me right here. Let me just erase that part. Right here, guys. X is the number of desks. So now we're going to make how many of them? 200. So I'm going to take 80 times 200 plus 5,000. Okay. So let's take our calculators, move this over here so everybody can see. 80 times 200, 16,000 plus another 5,000, is that 21,000? 21,000. Maybe we should be making desks, right? We can charge them $21,000. Okay. Now, we got a part C to this, guys, a third part. How many desks can be produced on a budget of $11,000? Okay, so let's see if we can figure this out. C equals 80x plus 5,000. Okay, how much money do we have to spend right now? 11,000. That's right. So guys, notice what Isaac says. Look, we have $11,000 to work with, but we already know we have to pay $5,000 in rent, electricity, all that kind of stuff. That's right. So we're really subtracting that $5,000 off to say, you know what, we really only have $6,000 to work with. And if every desk cost us $80 to make, what are we going to do with those two numbers now? Divide them out, right? So we're going to take $6,000 because that's really what we have to work with. And we're going to divide it by 80. And how many desks can we actually make? 75 desks, right? Boom. That's the, It depends on how much you're going to sell the desk for. But let's put it this way. If you're making those desks for $80, you got to sell them for obviously much more than that, right? You got to sell them for much more so that, number one, you can pay your $5,000, right? And then number two, you got to make some money, right? Because otherwise you're just breaking even, right? What's the whole point in doing that? Okay, so guys, take a look at the next one here. It says a 2005 Nissan Altima depreciates at a rate of $1,800 per year. If the car has a current value of $7,200, find an equation in slope-intercept form that models the value V of the car based on the number of years T. Okay, so guys, I'm going to write an equation, and it's going to look something like this. Okay, so remember, this is the rate. This is my fixed cost, right, or my initial amount. Okay, look what it tells me, guys. It says the car does what? Depreciates. Okay, what does the word depreciate mean? It's going down in value, okay? So look, we're going to go like this. V equals, I know it's depreciating, guys, so it's not just an 1,800, it's really a negative 1,800, right? Because it's depreciating. Depreciating means it's going down, right? Okay, what's the value of the car today, right now? $72, right? Or $7,200, right? $72, there we go. 7,200, boom. There's the equation that tells us the value of the car. Okay. Now look at the next part. It says, what's the value of the car after 2 years? Well, after 2 years, we're going to take negative 1,800 times 2 plus 7,200, right? So I'll take my calculator. So if I say, what's negative 1,800 times 2? 3,600 negative plus 7,200. Isn't it still 3,600? Yeah. So the value of the car after 2 years, oops, not that much, is only worth $3,600, right? Guys, I want to point something out. It's real important that I have that negative there, because if you look at my calculator, see when we did it, negative 1,800 times 2, negative 3,600 plus 7,200 gave me 36, right? If I would have done this, right, and then said plus 7,200, look at the number I would have come up with. Would that have made sense? No, because you know the car is going down in value, right? So the only reason I'm saying this is a couple of years back when I did these same problems, I always had a couple people who would give me something like that, right? And it's like, hold on, let's think about this for a little bit. All right, last part of the question. When will the car depreciate completely? Guys, if the car depreciate completely, what's the value of the car? 0. So 0 equals negative 1,800 T plus 7,200. All I'm trying to do here, guys, I'm just trying to get my T by itself. So look, I have two options. I can either move my 1,800 or I can move my 7,200. I'm going to move the 1,800 because then it becomes a positive 1,800. Okay. And if we divide both sides by 1,800, then if I take my calculator again, right, 7,200 divided by 1,800 should be 4. There you go. So 4 years, right? Takes it 4 years to depreciate completely. After 4 years, they will, right? I bought my brother's Nissan Versa like 2 years ago, and it's a 2007, and it's probably not worth a whole lot, but $20 a week in gas, I'd rather use that than my truck. You know what I mean? All right. So guys, one more problem. Actually, I think we got 2 more problems. Right? 2 more problems. Okay. So let's do this one here. It says Al starts a new diet and workout regimen He currently weighs 286 pounds and losing in weight at a rate of 2.5 pounds a week. Find an equation of slope-intercept form that models Al's weight W based on the number of weeks X. Okay, so we're going to write an equation, guys. It's going to look like this. MX plus B. Al is my brother, by the way. All right, so let's see. W equals. Okay, Al is losing weight. Because he's losing weight at a rate of 2.5 pounds, would it be a positive or a negative? Negative. Negative 2.5 X. And how much does Al weigh right now? 286. Yeah, he's a big boy. Boom, there we go. Okay. Now, let's take a look. What's Al's weight after 10 weeks? Okay. So we're going to go like this. W equals negative 2.5 times 10 plus 286. Okay. So I'll take my calculator again. Negative 2.5 times 10 plus 286. He is now down to 261. Okay. And the last part of it, guys, says how many weeks will it take Al to reach his target weight of 240? So we're going to go like this. We're going to take the same equation that we have right here, and we're going to put that 240 right there equals negative 2.5x plus 286. So the first thing I'm going to do is I'm going to say, let's get rid of that 286 by subtracting it. So if I take my calculator and I say, what's 240 minus 286? Is that 46 pounds? Right? Okay, so we have a negative 46, right? Because it says his target goal is to weigh 240. All right. So guys, if he basically wants to lose 46 pounds, right? Because he originally weighed 286, he wants to get down to 240. That's basically losing 46 pounds. If he's losing weight at a rate of 2.5 pounds a week, what am I going to do with those numbers now? Just divide them out, right? So divided by a negative 2.5 equals 18.4. There you go. 18.4 weeks, right? All right. So guys, last problem right here. Let's take a look. It says the graph below shows the value of a machine used to produce faucets, where Y represents the value of the machine in thousands of dollars after X years. What's the Y-intercept? What does the Y-intercept mean? And write the equation of the line that best fits the graph. Okay. So let's talk about this for a little bit. All right. So, guys, here's the year, and here's the value, right? So in year 0, what's the value of that machine? 20,000, right? Okay. So in year 0, the value of whatever this machine is, it produces faucets. Okay, it's worth $20,000. Okay. In year 1, what's the value of the machine? 16,000. Okay, guys, can we find the rate at which it's losing value? Subtract. Okay, so what's 16,000 minus 20,000? Negative 4,000 over how many years? How many years have passed here? 1 year, right? So isn't it losing value at a rate of negative $4,000 a year? It's going down in value, right? Okay. So that's the first thing I'm finding. I know it didn't necessarily ask me to write that just yet, but that's something that I wanted to find. Okay. Now, guys, the Y-intercept is the point where it hits that Y line right there, right? So what did we say? We said that in year 0, it's worth how much? Yeah, so we can just go like this. In year 0, the value is 20,000. All right, guys, that year zero and the value, that's our B. Okay. So remember how we're writing our equations like this, like V equals mx plus B, right? So all I'm going to do here, guys, is I'm going to write it like this. V equals, the rate at which it's going down is how much? Negative 4,000 per year. But it was initially worth how much? How much was the initial value? 20,000. There you go. That's it, guys. That's all it is.